So students, welcome to BEX lecture number 15. So today we are going to start with module oscillators. So in oscillators we are going to check why we require oscillator, it needs, and a definition of an oscillator. Then we'll go through the type of feedback, which is positive and negative feedback, and also which will be discussing about the condition for oscillations, which is described by Barkhoud's criteria. So let's start. I think in the last lecture we have started with the concept of feedback, right? So let us again discuss about positive feedback. I have discussed about open loop closed loop system, right? So we have drawn a block diagram which was looking just like this. We had an amplifier block, and this amplifier block has a gain A1. Then what do we have? We have a feedback network, yes or no, with a gain K. So gain of this amplifier network is A1. Now we have a positive block over here. Someone is asking any doubt? Yeah, anyone has a doubt? Okay, okay. Yes, you are writing. So here, this is my input. Let's say my input is X. Okay. Now this can be a input signal, and here is my output signal Y. Now this output signal Y is fed back to the feedback network. Let me draw this in different color. So this maroon color Y over here is my feedback signal. So my output is fed back to the input for the correction purposes. Okay, so this is my feedback signal. So output is somewhat related to input again for the correction purpose, right? Let's say that the output of the feedback network is determined by U. This is my feedback signal actually. U is my feedback signal. Okay, so here I can write U is my feedback signal. Alright, now this is my input. This is input signal. This is my input signal. This is my output signal. I think we have written all this last time. This is my feedback signal. Okay, so if in a positive feedback, if my input and the feedback signal are additive, both add ho rahe hain, so this becomes X plus U, then it's a positive feedback. So whenever the feedback signal gets added to the input signal, it's a positive feedback. समझ में आई ये बात? Understood this? Okay. Now, so feedback signal, output of the feedback network is U and input is Y, and this block is multiplied by K. So what will be U given by? K into Y. Agree? Okay. Next, X plus U is the input to the amplifier. So what will be the output of the amplifier? A1 times X plus U. Agree? Because it's multiplied with this block A1. So I can say my feedback signal is K into Y, and my output Y is given by A1 into X plus U. So instead of U, I'll substitute what now? K into Y. So now I'll take K Y this common, minus A1 KY is equal to A1X. Yes or no? So I'll take Y common, 1 minus A1K is equal to A1X. So what will be Y by X? See, Y by X, Y is my output upon input. So output of the system, output upon input, is called as transfer function. So this is A1 divided by 1 minus A1 into K. Are you understanding? Yeah. So this system is called as closed loop system. if I had just an amplifier, खाली amplifier होता मेरा gain, which x and y as the input, this was open loop. तो open loop system का gain कितना है? Gain is A1. And what is the closed loop system gain? Y upon x. समझ में आ रहा है ना? Gain of any system is output upon input. So y upon x basically, y upon x is my closed, ये जो सर्किट है ना A1 for feedback network, ये entire circuit का gain is closed loop gain, which is given by the formula A1 upon 1 minus A1 into K. And what is A1? A1 is the open loop gain. Open loop gain of this amplifier itself, that's it. Okay? Now, what can you say? Y upon x is greater than A1 or y upon x is less than A1? बताओ. Anyone? So let's take an example. Let's say the gain is 100 and the factor k is 1 by 10. बराबर है? So now example ले रहे हो. Now we'll do 100 divided by 1 minus 100 divided by 10. तो ये कितना हो गया? 100 divided by मैग्नीट्यूड ले रहे हो तो थोड़ा सा कम ही आएगा ये. दिस विल बी लेट्स से 1000. के लेट्स से 1000. सो कितना हो गया? 1 माइनस 0.1, राइट? यस और नो? सो 100 माइनस what will be this? 0.9. So is this greater than 100 or less than 100? Greater ना? कितना हो गया बताओ? Anyone can tell me in calculator what is y by x? This is y by x. How much is 100 divided by 0.9? Yeah, come on. It's 111, na? Is this greater than your open loop gain, which is 100? Yes. So it is definitely greater than this thing. So whenever the closed loop gain y by x is greater than the open loop gain, which is A1, I can say we are using a positive feedback. समझ में आई है बात? So first clue of a positive feedback is what? First clue is the feedback signal x, u and x are additive. Add हो रहे हैं. So this both the signs are positive. So x plus this is to getting added, of course. This also gets added. So x plus u it becomes. Agree? Okay? But under one condition, this can become dangerous. Can you tell me what is the condition? If somehow 1 minus a1k approaches 0. ये कब होगा? जब भी 1 will be equal to a1 into k. अगर ऐसा हुआ तो what will happen? What will happen to y upon x? So it will become a1 upon 0. What is 1 divided by 0? Infinity. Do you agree? Hello? Yes, no? So basically this a1 into k should never be equal to 1, but it should be closer to it, so that you get a large closed loop gain. Are you following? So this is what you called it as a positive feedback. So positive feedback, the output keeps on growing, you know, until it is limited by the non-linearities in the circuit. So output keeps on going, your input signal and the feedback signal are in phase. So for a positive feedback, x and u are in phase. Are in phase matlab both are positive, both are getting added. And secondly, what is the meaning of a positive feedback? When closed loop gain y upon x is greater than open loop gain a1. So these two are the conditions to determine whether it's a positive feedback. Okay? Understood everyone? Yes or no? Hello? Can you give me a feedback? Yes. Okay. Now see, I will do some changes. I don't know whether the changes will be visible. Now I'll be discussing negative feedback also in the same thing. So let's see what does the negative feedback mean. Negative feedback में ये negative रहेगा. That's it. This will be negative. So instead of x plus u, you will get x minus u. समझ में आई ये बात? Yes. So everywhere you will get a1 into x minus u. So let's solve this. U2 is ky only. So u is k into y only. What will be y given by? Y will be given by a1 into x minus u, right? Y will be x into a1 into x minus u. a1 into. Now I can substitute the value of u over here, a1 x minus ky. So if I what I will get if I club them together, it will be 1 plus a1 k y, okay, which will be a1 into x. So over here, what is y upon x now? a1 upon 1 plus k a1. Yes or no? So for a negative feedback, this is the derivation for the closed loop gain. So वहाँ पे क्या था हो रहा था पता है a1 upon 1 minus a1 into k था. Here it is what? a1 upon 1 plus k a1. Are you understanding what I'm trying to say? So here we are using a negative feedback. Negative feedback matlab my input signal x and u are not in phase. What do you mean by not in phase? One is getting added, one other is getting subtracted. So it becomes x minus u. So there will be some situations where you want to use a negative feedback and there will be some situations where you want to use a positive feedback. So negative feedback से क्या हो रहा है हमारे circuit में? Let's see, let's take an example. This is closed loop gain, y upon x. Closed loop gain. And what is my open loop gain? Anyone? A1. So यहाँ पे we'll take the example now. Let's say A1 is 100, okay, and K is let's say the value is around 110. Okay, so y, what will be y upon x? 100 divided by 1 plus this into 100. So what do you get? 100 1 plus, how much did you get over here? Plus 10. So y upon x will be 100 upon 11. Okay, so what is the number? 100 upon 11. 9.09, right? 9.09. Now you tell me y upon x is how much? 9.09. And how much is a1? 100. Which is greater? This is greater. So in a negative feedback, your closed loop gain y by x is very much less compared to a1. मतलब closed loop gain का the value of the closed loop gain is very less. Okay, compared to open loop gain. Open loop gain is 100 and closed loop gain is 9.09. So which is very far off. Okay, and then in the positive feedback में क्या हो रहा था? Output was keeping on growing. Okay, x and u were in phase and closed loop gain was greater than the open loop gain. In this case, in case of negative feedback, x and u are input signal and the feedback signal are not in phase. So y upon x, also y upon x is much less than a1. That means my closed loop gain is much lesser than the open loop gain. So यही एक drawback है negative feedback का, it reduces gain. Now which gain we are talking about? We are talking about voltage gain, current gain, we don't know. Now this input signal can be a voltage or current. This output signal can also be a voltage or current. I have written there y and x, but I really mean is it can be input can be a voltage quantity, output can be a current quantity. It's possible. Yes or no? Are you following up till now? Can I proceed ahead? You have any doubts, you can ask me right now. Anyone, the concept of positive and negative feedback is clear? Yes, no? If you have doubt, you can ask me. Hello? You're writing all these things, right? Can someone just inform me whether it's all going good? Can you explain the negative feedback again? Okay, fine. I'll explain the negative feedback again. Okay, let me explain with the help of
positive also.
You have joined late or you were there?
No, sir, I will there.
Okay, let me briefly explain again. So you have an amplifier block with a gain A1. समझ में आया ये इतना? You have a feedback network with a gain K. ठीक है? Now your input signal is coming over here X, which is going to the A1, and here you have output signal Y. Alright? ठीक है? Now some part of this output is connected to the feedback network, and feedback network output goes to the input. Okay, so this signal is called as U. Agree? So what we are saying is, when this input signal and feedback signal are both additive, that means यहाँ पे क्या हो रहा है, x plus u आ रहा है. During that time we say it's a positive feedback. समझ में आया? सेकेंड चीज पॉजिटिव फीडबैक में क्या है कि y अपॉन x, ये सिस्टम का गेन, द गेन ऑफ दिस सिस्टम इज ग्रेटर देन a1. ये है मेरा ओपन लूप गेन. मतलब व्हेन आई नॉट कनेक्ट द फीडबैक तभी गेन क्या था. व्हेन आई कनेक्टेड द फीडबैक द गेन हैज इंक्रीज्ड. ओके, सो दिस मीन्स दैट if you keep on increasing the value of k here a being constant, so y by x will keep on increasing. Okay, and at one particular value of k, 1 minus a1 into k will become 0. So that time y by x will become infinity. So this means that even without the input signal, the amplifier will keep producing the output signal with the help of feedback signal. समझ में आया ये क्या बोल रहा हूँ? तो okay, let me write the output expression. It's a1 upon 1 minus a1 into k. Okay, ये समझा है? In case of a positive feedback, this number, this factor, it's greater, y by x is greater than a1. This is the consequence of positive feedback. Now let's say for some reason you go on increasing the value of a1 is constant. A1 is constant and you go on increasing the value of k. Now at one point of value of k, 1 minus a1k will become 0. So during that time what will happen? Y upon x will become infinite. Matlab the gain of the entire system will become infinite. So if that happens, then that means even without the input signal, the amplifier will keep producing the output with the help of the feedback signal, because feedback signal तो जा रहा है ना. अगर x को 0 कर दिया यहाँ पे, let's say, so still u2 is there na, it will keep on amplifying u, right? This will amplify by k, this will reduce by k. Are you getting it what I'm saying? So provided your a minus 1 minus a1 into k becomes close to very much close to 0. So this is the concept of positive feedback. Any doubt, anyone still? Hello? So in a positive feedback, in summary, what all things happens? So for a positive feedback, x, which is input signal, and u are in phase. मतलब दोनों almost same phase में है. Okay. Second चीज, my closed loop gain, which is y upon x, is greater than my open loop gain. Okay, that means my output will keep growing. So if my output signal is like this, it will keep on growing above if it is not limited. Are you understanding? And this situation will happen when this condition is reached. ये whenever denominator tries to become 0, my y by x will try to become infinite. So इससे क्या होगा? इससे y by x will become try to become infinite, very 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 high. So उससे even without the input signal, now अभी अगर x 0 कर देते हैं, still my system will be driven by the feedback signal. So the amplifier will keep on producing the output voltage with the help of feedback signal now, even if x becomes 0. समझ में आ रही है बात? Yeah? Hello? Okay. So this is where your amplifier, your system start operating as an oscillator. So this is the starting point of oscillator. Oscillator works with positive feedback. Oscillator requires an amplifier with positive feedback to work around. So this is number one condition for the oscillator to require. Now we'll see shortly what is an oscillator, how do you define it, what is the need of an oscillator shortly. पर ये positive and negative feedback का concept समझाए. So for a positive feedback, what happens? The output will keep on growing. At one point of time, अगर ये condition reach होता है, तो output will keep on growing even without the input signal. Even if x becomes 0, it will keep on growing at the output like this. And this will lead to oscillations. So oscillator will require amplifier with a positive feedback, and this is the amplifier with a positive feedback. समझ में आई ये बात? Now I'll explain the negative feedback. Is this clear to you now? Yes, no? तो लिखो यहाँ पे. Write one line, very important line. Number 1, an oscillator is an amplifier with positive feedback. We'll very roughly write the definition of oscillator. What is an oscillator? So you can write over here, an oscillator circuit. Please write along with me. An oscillator circuit provides a periodic sinusoidal wave. You know now what is a sinusoidal wave? ऐसे ये sinusoidal wave है. समझ में ये देखा है कभी पहले? Yes, this is a sine wave. An oscillator circuit provides a periodic sinusoidal wave of adjustable amplitude of any desired frequency. Okay, that's the definition of oscillator. An oscillator circuit provides a periodic. What do you mean by periodic? Anyone knows what is periodic? मतलब अगर ये मेरा एक साइन वेव है, ये एक मेरा पीरियड है, so it will keep on repeating itself afterwards. Yes or no? इसको बोलते हैं periodic signal. मतलब after one cycle, it will keep on behaving the way it was behaving first case. So this is the second cycle. Again, it will keep on behaving the same case in the next cycle. Like this. Okay, so this is my periodic signal. This is normally a sine wave, right? So what does an oscillator circuit do? Oscillator circuit will generate this wave or sine wave. Correct ना? Oscillator circuit से क्या होता है? Generate this kind of a waveforms. समझ रहे हो? Yes, no? So what is the definition of an oscillator? An oscillator circuit provides a periodic sinusoidal wave of adjustable amplitude and desired frequency. So you can adjust the amplitude of this waveform. We can adjust it, we can make it more larger like this. So this is with a higher amplitude. So this is how you keep a check on the oscillator. So you can have an adjustable amplitude and any desired frequency. So you set the frequency, you can get an oscillator of that particular frequency. So this is what the definition of a oscillator is. समझ में आई ये बात अभी? Yes, no? Quickly tell me.
Yes.
Okay. Now negative feedback एक बार बता देता हूँ revise and then we'll go to the main topic because we already short of time. So negative feedback में क्या होता है? ये gain amplify with a gain A. Then we have feedback network with a gain K. Here we have the summation block which will add two signals X and U. Oh, X and U, yeah. And this is going over here in the feedback network and output is Y. So whenever X is plus and feedback signal is minus, that means it's a negative feedback. So negative feedback always will reduce the overall gain. So over here what will happen due to negative feedback? What will consequence will happen? Tell me. Number one, X and U are not in phase, correct? Then what else we can write? Y upon X, we have seen this is much less compared to A1. So my closed loop gain is much less compared to output. So here output will be low to moderate. It won't be very high at all. So output will be limited over here. It will keep on. यहाँ पे क्या हो रहा था पता है? The output was keep on growing, right? Here it will keep on slugging down. Meaning output अगर ऐसे है तो it will keep on reducing until you know have some mechanism to pull it up again. So this is what negative feedback is, and negative feedback is not used in oscillators. It's used in adder circuits. Amplifier circuits. So this is useful. Negative feedback is useful in amplifier, but I've taught you the concept. Okay. So can we write now the definition, formal definition of oscillator and its need for the next 10 minutes? Are we ready? Yes? Can we start? Okay, so write down. First we'll write down the definition. Now we have completed these two topics. Listen over here. Positive, negative feedback, khatam. This is complete. Now if you have any doubt, you can watch the recording again. Yes, last lecture I've given you example, practical example of an air conditioner, room setting temperature also. Car braking system I've explained. Negative positive feedback is over. Types of feedback is over. Now we have oscillator need and definition, and then the Barkhausen's criteria. So let's start with the definition. So likho, everyone, write down along with me oscillator definition. Okay, so point number A, write down oscillators are electronic circuits. So let me draw a block of an oscillator. It doesn't require any input, it requires VDD and it produces the output Y. And the output of the oscillator will be a periodic signal, may not be sinusoidal always, it can be a triangular waveform also, it can be a sawtooth waveform also, it can be a square waveform also. Okay, so oscillator can produce any of these wave shapes with a constant with adjustable amplitude as well as frequency. So oscillators are electronic circuits that generate, the proper definition, yeah, that generate periodic electrical signals known as waveform with a specified with a specific frequency and amplitude. Do you know what is the frequency and amplitude of any signal? Are you aware of it, or can I explain? Do I have to explain this also? Can I explain? I mean, should I explain this topic again? I mean, yeah, have you heard of this? Yes, no. Periodic का मतलब समझा है तुम्हें? So this is called as sine waveform, sinusoidal waveform. This is called as square waveform. इसको बोलते हैं waveform. This is called as sawtooth waveform. So let me read what answer you have written. Explain. Okay. Now let me consider a sinusoidal signal. उसका frequency and amplitude बताता हूँ. So ये मेरा sine wave है. Okay. This is sine wave, and I have another sine wave. This is time, of course. This is amplitude of it. तो ये मेरा height of this waveform is my amplitude. So what is the height of this waveform? This is amplitude. ये वाला part. ये height को बोलते हैं amplitude. Like any human being standing up front, you can measure their height. Similarly, the sinusoidal, this is AC signal or sinusoidal waveform. This is sinusoidal waveform or sine waveform. Simply you can write sine waveform. Yes or no? So this is the amplitude. Frequency कैसे measure करोगे? Frequency you will measure it until the waveform becomes repetitive. So यहाँ पे repeat हो रहा है ना? Okay. So this is my time period, capital T, of the signal. इसके बाद year after the waveform gets repeat. तो यहाँ तक this is one time repeat. From year to year it repeats once, it goes to 0, again goes to negative, again goes to 0. This is one cycle. And the second cycle starts over here. See, it's again repeating, following the footsteps of first cycle. So this is what do you call as, हाँ अभी frequency कैसे define करते हो? 1 upon time period is frequency. So ये जो time period मिला, 1 upon time period will give me, this is time period and this is frequency. Are you understanding what I am explaining, everyone? So oscillator क्या करता है? ये signals को generate करता है. And when do we say a periodic signal? So ये जो sine wave है, is it periodic or no? Yes, periodic मतलब the period will be fixed and it will keep on repeating itself, let's say 1000 times. हमारा जो AC mains है घर पे जो single phase supply आता है, that also is a AC signal. This is a AC signal. AC mains बोलते हैं ना हम लोग उसको, 230 volts 50 hertz. It's the same cycle. So same waveform. इसको बोलते हैं sinusoidal waveform. Okay, or sine waveform. Whose time period is T, frequency is 1 upon T, and amplitude is A, let's say. Okay, so let's continue, go to the definition of sinusoidal signal of your oscillator. So what you have written? Oscillator are electronic circuits that generate, ये important है, that generate periodic electrical signals known as waveforms with a specific amplitude and frequency. तो ये circuit का भी कुछ ना कुछ amplitude रहेगा, right? Let's say it's 10 volt and इसका वही frequency रहेगा, let's say it is 50 hertz, and corresponding to 50 years there will be a time period. Okay, so let's continue the definition. I hope it is clear now. What is a sinusoidal signal? What is a periodic signal? Yes or no? Its amplitude and frequency, how do you measure it? Come on, tell me fast. Understood this topic?
Yes.
Okay, very good. So here let's continue writing the definition. This is the definition. Oscillators are electronic circuits that generate periodic electrical signals known as waveforms with a specified frequency and amplitude. These signals can take various forms such as, मतलब ये वाले सारे सिग्नल, such as sine wave, triangular wave, just I have described over here. यही सब है ना? This is triangular wave. Then you have or sawtooth wave, or we can write square wave. So these signals can take various forms such as sine wave, triangular wave, sawtooth wave and square wave as I have drawn over here. Okay? Yes or no? Depending upon, continue writing, depending on the design of an oscillator. So not all the oscillators will produce the same signal or the similar signals. So these signals can take various forms such as sine waves, triangular waves, sawtooth wave and square wave depending upon the design of the oscillator. Are you understanding it? Yes? So this is the definition of oscillator. If they ask you in the exam, will you write it properly? Students, yes या no बोलो जल्दी. We are already short of time.
Yes, yes.
Will complete its need and definition and then we'll break it for today. तो इसमें A point लिखा है ना, अभी B point लिखो जल्दी, quickly. So oscillators, continue to write, are fundamental components in electronic systems and serve as serve purposes such as, so it will function these things, it will serve purposes such as generating clock signals for, ये बहुत ही important point है, this will tell the need कि क्यों चाहिए oscillators. ये explain क्या कर रहा है? What is it explaining? Explain the need of oscillator. ये आंसर लिख रहे हो तुम लोग. Okay? Understood? So oscillators are fundamental components in electronic systems and serve purposes such as generating clock signals for digital circuits, producing, just keep on writing, carrier signals for communication systems, generating carrier signals for communication systems. Next point is, keep on writing, providing reference signal providing reference signal for measurement and testing equipment and generating waveforms for signal processing and modulation applications. Okay, so these points you have to write forward for the answer to the question. Explain the need of oscillator. Okay, there is a few more points, one last point which you can add. Have you completed up till here? Okay, last point is they are essential for maintaining. They matlab, what is the meaning of they? They means oscillators are essential for maintaining timing, synchronization and stability in electronic devices or electronic circuits and systems. Alright, so this is the answer to the question. Explain the need of the oscillator. So you will explain. Please write it down. Oscillators are fundamental component in electronic systems and serve purposes such as generating clock signals for digital circuits, providing carrier signals for communication systems, providing reference signals for measurements and testing equipment, and generating waveform for signal processing and modulation applications. They are also essential for maintaining timing, synchronization and stability in electronic circuits and systems. So this will be your answer to the question of explain the need of oscillator. So we have completed. You have completed this topic? Yes? Hello?
Yes, sir.
Okay. Excellent. So इसका more advanced answer I'll give it to you in writing in this PDF only. मतलब if you want to explain more about need of oscillator, I'll give you in writing this meaning over here. मैं add कर दूंगा इसमें, which will be available and not waste any more time now. And so today we have completed what? We have completed the need. Correct now? The need, the definition of oscillator. Type of feedback signal, positive signal, negative, positive feedback we have completed. Barkuson's criteria due to time limit will complete it next time. Okay, in the live, in the classroom live. Alright, so we will break it for today then. We'll end it here, the lecture. I hope you have followed, and if you have any doubt, you can ask me before I leave for today. Let me stop with the recording also.